Hello students, today we are going to discuss about very important theorem of differentiability. That is, prove that if a function f is differentiable, we have given a function is differentiable at a point c, then it is also continuous. At that point. Means what we have to prove, if function is differentiable at a point c, any function which is differentiable at a given point c, then it is also continuous at that point. Now we know very well when function is continuous. When function is continuous, then their limit x approaches to c, f of x is equal to f of c. That you know very well. When function is continuous, if limit exists, then left hand limit is equal to right hand limit is equal to limit at that point. So limit is, when limit is exist, limit x approaches to c, f of x is equal to f of c. So this is a condition for when function is continuous. So it means we have to prove the function which is differentiable at a given point, then it is also continuous at that point c. So let's start with this one. Now as we know, a function is differentiable at point c, then f dash c is equal to limit x approaches to c, f of x minus f of c upon x minus c, where x is not equal to c. This is a condition when function is differentiable at a given point c, then this is also always equal to limit x approaches to c, f of x minus f of c upon x minus c. अब आप बोलेंगे सर कल तो आपने जो फॉर्मूला बताया था वो फॉर्मूला हमारा कुछ इस तरह से था, limit h approaches to 0, f of c plus h minus f of c upon h. This is f dash c. बट आज हम फार्मूला ये यूज़ कर रहे हैं. एक्चुअली बोथ फार्मूला आर सेम. Here I am using this one formula with f of x. Why? Because we have to prove the given function which is differentiable, it is also continuous at that point. So because here, if I am putting here, put x is equal to c plus h, and limit, if x approaches to c, then h approaches to 0 here, and your formula becomes limit c, limit h approaches to 0, f of c plus h minus f of c upon c plus h minus c. C cancel out, limit h approaches to 0, f of c plus h minus f of c upon h. Now see here, this formula and this formula both are same. That's why I'm using this one formula. So let's start with this one formula. So you should know about this one. When function is differentiable, a function is differentiable at a given point c, then f dash c is always equal to limit x approaches to c, f of x minus f of c upon x minus c. Now here I am considering this one, f of x minus f of c. We can write f of x minus f of c is equal to minus f of c upon x minus c to x minus c. See what we did here? I am multiplying here, multiplying and dividing by x minus c. In next step, what we have to do, taking limit x approaches to c, both sides. When we are taking limits both sides, then we have limit x approaches to c f of x minus f of c is equal to limit x approaches to c, f of x minus f of c upon x minus c into limit x approaches to c, x minus c. Now by using algebra of limits, limit x approaches to c, f of x minus limit x approaches to c, f of c is equal to, now see, this is equal to from 1, this is equal to f dash c. So here we can write this is your f dash c, multiply and apply direct limit here, put x equal to c, then c minus c is equal to 0, or this is equal to limit x approaches to c, f of x is equal to, this will go this side, this is equal to f of c alone, because here no x is here, so we can write this is equal to f of c. Now see, we proved that limit x approaches to c, f of x is equal to f of c. What does it mean? It means function is continuous at that point. I already told you when function is continuous, when limit x approaches to c, f of x is equal to f of c. Here we are considering function is differentiable at a given point. As we know function is differentiable at a given point, then f dash c is equal to limit x approaches to c, f of x minus f of c upon x minus c, and here x is never equal to c. So in next step what we did, we can write f of x minus f of c is equal to, here I am multiplying and divided by x minus c, f of x minus f of c divided by x minus c and multiplying also x minus c. Then after that taking limit x approaches to c both sides. After considering the limits, we will get this one. Then apply algebra of limits. Then from 1 this is equal to f dash c, and here apply direct limit, it becomes 0, and we will get result after that limit x approaches to c, f of x equal to f of c, and at last we have tried, hence function is continuous at x equal to c. So now we have a theorem that is every function which is differentiable at a given point c, then it is also continuous at that point. Okay, but converse is not true, that every continuous function is not a differentiable function. Here I'll give you example of this one. See, if I am considering f of x is equal to mod of x. Now as we know, mod of x, modulus function, every modulus function is a continuous function. Now see, this modulus function is not differentiable at a given point x equal to 0. So at x equal to 0, now let's start with this one, at x equal to 0, if it is differentiable, then what does it mean? It means the left hand derivative should be equal to right hand derivative. So if it is differentiable at x equal to 0, then left hand derivative should be equal to right hand derivative equal to finite value. So firstly let us consider the left hand derivative. In left hand derivative what we have to write, limit h approaches to 0, f of, your formula is c plus h, but here c is 0, so we can write 0 plus h minus f of c, c is here 0, here we can write f of 0 upon h, or limit h approaches to 0, so f of 0 plus h. Firstly left hand limit we have to consider from left side. So f of 0 plus h. So what is f of 0 plus h? F of 0 plus h, here we have to write f of 0 plus h. So it becomes 0 plus h minus f of 0 whole divided by h. Now if we are considering limit h approaches to 0, limit h approaches to 0, and here this is equal to h minus here this is your 0. Now here h, where h approaches to 0 negative, when h approaches 0 negative, then this is equal to negative of h. So here this h cancel out and this is equal to minus 1. Similarly in right hand limit, in right hand derivative, we have limit h approaches to 0 positive, and here 0 plus h minus 0 upon h. Now from 0 positive, from right hand side, when x is greater than 0, then mod of x equal to x. So here this is equal to h minus 0 upon h when limit h approaches to 0. So h cancel out, this is equal to 1. Now see here left hand derivative is your minus 1, here right hand derivative is 1. So left hand derivative is not equal to right hand derivative. It means function is not differentiable at a given point, but we have function is continuous. So we can prove that function is continuous. Every function which is not which is continuous is may or may not be differentiable, but every differentiable function is continuous at a given point. I hope you understand this one. Okay, thank you. Have a nice day.